Tonight we begin the first of a 7-part series on Mount St. Helens. We've lived with the rejuvenated volcano, all of us, for more than a year now. The week-long series is a look ahead, going beyond what we already know about the mountain and its effects. We lead off tonight with a report from Tim Storrs on the volcano itself.
The eruption of May 18th was triggered by an earthquake of 5 on the Richter scale, which in turn touched off a landslide. From the crater, this is the path of the slide and the pyroclastic flows, fiery walls of ash, rock, and gas traveling more than 3 miles a minute, burning what they did not vaporize, eventually stopping 17 miles north from the crater. Canyon walls were scoured, trees and earth wrenched from hillsides, exposing bare rock like flesh ripped from a bone. Creeks running down the slopes of Mount St. Helens have been replaced by still rivers of pumice rock, its flowing symmetry born of random placement. This was carried down the north flank of the mountain by eruptions in August. The volcano is churning out the newest and consequently the youngest rocks in the world. It has become, in effect, a 200-square-mile geological spawning ground and laboratory studded with electronic equipment. With it, geologists have learned to read the mountain signals, its combinations of earthquakes and high-frequency tremors that are usually followed by eruptions. It's here at the University of Washington that Mount St. Helens is monitored by a network of seismographs. More than 100 are located all over the state of Washington. It is through them that geophysicists are finding growing evidence of a major geological fault, one running in a line from Mount St. Helens to Yelm, Washington.
It's not just developing at this point. It may be getting more active at this point due to the same kind of stresses that is ultimately causing the eruptions, or there may be a cause and effect relationship.
Hundreds of earthquakes have hit the area of the fault line since the first eruption last year. The activity along it so far has been subsurface, though geologists are looking for evidence of stress on the surface of the Earth.
This fault could possibly be one means of transport of the magma into the Mount St. Helens area, but that's simply a speculation.
The fault is one more symptom of the physical stress the region is under now. Though unseen, it is no less a powerful force. The mountain seems to have taken on a life of its own. It sounds like a breath at times obscured by the near-constant swarm of aircraft near it, many of them carrying field crews of the Geological Survey, measuring the vital signs of the volcano as if it were a mental patient in intensive care, one at times quiet, at others raging. The dynamics of this volcanic system are not always as apparent as an eruption or a steam burst. This small lake that's come to be known as the Pumice Pond is still pretty hot. Out near the center, it's close to 210 degrees. But on its shore, where the pumice pebbles are still located, the water is in fact boiling. The surface of the mud and ash flows need only be scratched to release heat. The temperature of the steam from even small fumaroles around the mountain ranges from a comfortable 97 degrees to more than 1,400 degrees. The heat locked in by air-filled pumice as effective as any insulation. The fuming is expected to continue for at least another year. The volcano has been a gold mine for researchers. Geologists have reached the point where they no longer must rely exclusively on historical records of eruptions to forecast what will happen next, an ability that did not exist a year ago to anyone studying volcanoes in the Cascade Range.
Look at the short-term indicators, what's happened over the last few hours and days, and see if there's anything in those that gives you a hint about what the nature of that eruption is going to be. Sometimes there is. For example, over the last 3 non-explosive dome-building eruptions, the seismicity has increased and then reached a plateau and stuck at that plateau for a while and then backed off a little bit. And that might, if we get another you get another buildup of seismicity going off to a plateau, that might it tips the balance in favor of having a non-explosive eruption. In contrast with the explosive eruptions, when that seismicity started to increase, it just kept on increasing exponentially until the actual explosive eruption.
That's based primarily on the pattern of the last 3 eruptions, a pattern, it should be noted, that can change at any time. The very nature of Cascade volcanoes is explosive and unpredictable enough that anything can happen.
We expect that it is possible, and I have to caution it's possible, that we could have an ash eruption somewhere in the near future for Mount St. Helens that puts out as much ash as it came out on May 18th, 1980, or even more, and that the damage it would do would depend on the wind directions.
That remains a real possibility, along with almost any other scenario imaginable, primarily because scientists cannot see under the mountain to the source of the eruptions.
Our biggest question is not when the volcano is going to erupt, because our monitoring is very good and we feel we can give minutes or hours of warning, but what kind of an eruption will it be? Because the nature of the eruption is what causes all the damage. And we think that with the work we're doing at Mount St. Helens, we're going to add new information that's going to help geologists assess something that's going on 5, 8, 10, 20 miles below the Earth's surface.
The only certainty here is change. Features prominent now may not be so evident next year. They do not easily withstand the constant erosive pressures of wind, rain, snow, periodic eruptions, and superheated flows of ash and gas. Even the crater is no longer as it was after the May eruptions. It is rebuilding itself. It is possible the lava dome could continue to grow and eventually fill the mile-wide crater, restoring the rounded top that was blown off. It remains a mountain in transition. In the red zone near Mount St. Helens, I'm Tim Storrs, Channel 2 News.
Tomorrow, Jim Hyde takes a look at the lakes.